Okay, so you need to turn to page 223.
Wait, what is it?
223. Okay. Now, some of you may be confused because what chapter did we end with?
Triangle.
Chapter 5. And we're starting with chapter 8. This is why I'm doing this. We're coming back to chapter 6 and 7. Okay.
We're having to know peace, Jenna.
Yeah, you're ruining this.
No, we're having to know peace.
I'm waiting. Okay. We are going to start with chapter 8 because we just finished congruent triangles. Chapter 8 is about similar triangles. So I figured let's at least do something that kind of meshes with where we ended. I also think that since chapter 8 is short, it would be a nice just like jump start into the semester. And then we'll do chapter 6, chapter 7, chapter 9, so on and so forth. Okay. The last chapter is area and volume. I think it's 11.
So we're doing 6, 7, 8, 9, 10, 11.
This is short. A couple of them are pretty short. Okay, so a similar figure. We talked about congruent triangles last chapter. Now we're going to talk about similar figures. So raise your hand if you can describe to me what a similar figure means.
Figures that are similar.
Figures that are similar. Emily. Okay. Same shape, but not the same size. So I really like that she said congruent angles. Okay. Have we done something in this class, maybe last semester, where our figure was the same shape but different size?
Yeah.
Okay.
That is corresponding. Yeah.
Okay, so we're talking about dilation. Okay. So the angles in our two figures are all the same, but their sides are not. Okay. Now, when we have similar figures, okay, our corresponding angles are going to be congruent, but our corresponding sides are going to be what? Not perpendicular. Yes, proportional. Proportional, what does that have to deal with? Ratios.
I don't.
What? 23.
But not 12. I thought it was 24.
On normal days. Today's a Wednesday. Okay, so let's talk about corresponding parts of our similar figures. Drew, are you okay? No. Bryce, are you causing issues already? Apparently relationship was the wrong word for me to use. Sorry. Okay. I am telling you that trapezoid ABCD is similar to trapezoid WXYZ, and I want you to draw this.
What's that line?
Similar. This is our symbol for similar. It's like this is congruent. If we erase the equal sign, that's our similar symbol. Does that make sense?
So congruents are equal and similar? Or is that just like?
Yeah.
Oh, all right, we talked about this with, another. Right, because there's like smaller, but it's like the same. No.
Okay. So we know that angle A is congruent to angle W because those are in corresponding places. Angle B corresponds with X, so those two angles are congruent. Okay. Angles C and Y are congruent, and then D and Z are congruent. Just like with congruent figures, similar figures are also going to have corresponding angles congruent. Okay. Now, when we talk about proportional sides, that means we can set up the ratio of our corresponding sides, and it's going to be the same throughout the whole figure. So what I mean is side AB corresponds with side WX. If I make a ratio, it's going to equal the same ratio as if I take BC over XY. Will equal the same thing if I take CD over YZ. Will equal the same thing as AD over WZ. Now, these ratios, they're all going to equal each other. And we're going to call it K. This is our scale factor. Remember the scale factor back in dilations? Oh, so terrible. So terrible. It's going to be okay.
Just like.
Okay. How about you go ahead and turn to the next page? I am going to take those same two. Okay, and I'm going to give you some numbers to label.
Oh, so it's just like dilations, but with the sides.
I mean, it's just like dilations, yes. But we need to like set them up a little bit different, okay? So, can you see a pattern? Zach, you noticed a pattern. What did you notice? Okay, so you see this list times 4 divided by 4 relationship. Okay,
It goes red and blue, red and blue, red and blue.
thank you for that observation. Outside the trapezoid. So if I want the scale factor from A, B, C, D to W, X, Y, Z. I'm gonna pick 2 corresponding sides. So I'm gonna pick these 2 right here. The scale factor is a ratio.
I have a question.
Yes.
What does scale factor be for? It'd be 4 over 1. Over 1, yes.
No.
Because if you look at every single one, it's all like.
Yep.
If you times that, all the sides by 4, it'd be 16, 12, 8.
So Cohen, if I want to go and switch right now. If I want to go from A, B, C, D to W, X, Y, Z, if I want to go from this guy to this guy, it's getting smaller. So we actually have to set up our fraction in the reverse order. So I know I have A, B, C, D written first, but I'm going to set up my fraction upside down so that this is the number I would multiply to A, B, C, D to get to W, X, Y, Z. Okay. If I want the scale factor from W, X, Y, Z to A, B, C, D, then we would take 16 over 4, and yes, it would be 4 over 1. Okay, go on. Okay, all right, now over here, I'm gonna draw 2 triangles. I'm gonna draw A, B, C. And L, M, N. Okay, so I want you to draw these 2, okay? So I want to know, are these 2 triangles similar? You're just flat out saying no. Why?
The only thing they have in common is that they're triangles.
Okay, so I have a question. What's 67 plus 73?
140.
140, so that means this guy's 40?
It is the same. It's just.
So our angles are the same? Okay, so our angles are congruent. So that's good. Now we better check our sides. Are our sides proportional? So I'm going to take the smallest side over here and match it up with the smallest side over here. What's 4 over 2? Okay. If I take the biggest one and match it up with the biggest one, I have 12 over 6. Oh my gosh. And if I take the medium over the medium. Okay, so our sides are proportional. Are these 2 similar? Yeah, we would say that triangle ABC is similar to triangle A corresponds with M, B corresponds with N, and C corresponds with L. I just said A, B, C, and then I just picked the corresponding pieces to make sure that like A and N were in the same spot. B and N were in the same spot. All right, so before we talk about perimeters and area, I want you to move over here to this extra practice. Okay, this isn't gonna be your homework. I wanna like literally talk about the extra practice. So go ahead and look at 3 and 4. I want you and your elbow partner to determine the scale factor from ABCDE to KLMNP and vice versa. I would pick sides with nice numbers. Okay, you and your partner decide what is the scale factor both ways. Ready, set, go.
Emily, I win.
I'm the one bigger.
It is not 1/2. There's a 3 and there's a 2.
Yeah, I really good. Okay, so it's 1 and 1. If you say that.
Alright, 1.5. 1.5.
So 3 halves.
You guys.
Where do you put that? Oh, right. 2/3. Next 5.
Oh, yeah. Oh, yeah. Okay, Carson, what do you have for the scale factor from ABCDE to KLMNP? 3/2. Do you agree with that? Okay, so remember, the first one is for our denominator, the second one is our numerator. And we know it's right because if we started with a side from ABCDE and we multiply it by the scale factor, we get to the next figure. Do you have a question, Zach? Your eyes are acting like they have a question. Okay, Zach, so what's the scale factor? 2/3. Perfect. Okay. Now, let's go look at number 2. What if I say, hey, these are similar, find me the missing value? Which side corresponds with X over in this triangle? 25. So we can write a ratio of X over 25. And we know that that has to be the same ratio as another pair. So like what corresponds with 8? What? 8 and 20 correspond? So I can say, well, X over 25 equals 8 over 20. No. Cross multiply 20 times X equals 25 times 8. Huh? Could have what? Not worth our time, sweetheart. Not worth our time. If you have a proportion, yeah, you are right. But if you have a proportion, cross multiplying is going to be your most efficient solving method.
I
I
wasn't
was the
saying
one
that
that
I
said
would.
it.
I was just saying that that's what he was going to say.
Okay. Okay, here we go. The perimeter of a similar polygon has the same ratio as the ratio of the sides, okay? So let's say right here that this side is 10 and this side is 15. I'm like back on the left page. So draw this arrow. what would our scale factor be? 15/10, which is 3/2. And we're gonna leave it as 3/2. Now, what this is saying is the ratio of the perimeter is equal to the ratio of their sides. So our scale factor is 3/2. So the ratio of our perimeter is also that scale factor of 3/2. So if the scale factor is 3/2, if I add all the sides in the little one and all the sides of the big one, the perimeters are going to have the same ratio as whatever that scale factor is. Okay. Now, is that going to be the same for area? No way. Area is a two-dimensional calculation, okay? So if we have this same thing and our scale factor is again 3/2, this is saying that the ratio of our areas is going to be the same ratio but squared. I like square units, right? Okay. So the ratio of our area is going to be our scale factor squared. So in this instance, it would be 9/4. Who said, huh? I definitely have yours. Thank you for interpreting exactly what he said.
I hope he's joking.
Cohen, is that your laugh? It's an amazing, amazing laugh.